All right, logarithmic differentiation is something that sounds a lot more complicated than it actually is. It's just regular differentiation, regular derivatives, with a couple like extra steps at the end. And it involves logarithms, so if you're not very good with your logarithm properties, then you'll struggle a little bit. So I just recommend that you're really solid on that before you learn this content, because I'm going to assume that you know that stuff already. But you use logarithmic differentiation when you have a derivative which has your unknown variable in the base of an expression and in the like in the superscript, the exponent position. Like in this case, so we have y equals x to the sine of x. And if you didn't know any better, you would say that this derivative was sine of x times x to the power of sine of x minus 1. And you would try to use the power rule. The reason why you can't do that is because the power rule only applies when you have a variable raised to a constant. In this case, you have a variable raised to a function of a variable, sine of x. So you can't use the power rule. So this is no good. So instead, whenever you have function of x in the exponent position, like I said, you want to use this fancy process called logarithmic differentiation, which hopefully I can convince you guys that it's not as fancy and confusing as the way it sounds. So the first step to do any problem like this is you want to take the natural log of both sides. You'll see why here in a second. So I'm going to rewrite this as ln of y equals ln of x to the sine of x. So the reason I did this is because now we can apply the property of logarithms where if you have an exponent inside the argument of the logarithm, you can bring it down in front. So I'll rewrite this as ln y equals, bringing this down, sine of x times ln of x. Okay, it's at this point where we actually do the derivative now. So the next step in any logarithmic differentiation problem is do d dx of both sides, take the derivative. All right, so these derivatives are a lot easier than the original function because we've used the property of logarithms. So now all we have to do is the chain rule on the left side and the product rule on the right side. So let's do that. On the left side, we have that the derivative with respect to x of ln y is just y prime over y. And on the right side, we have the product rule. So we just do derivative of the left part times the right part left as it is, plus left part left as it is times derivative of the right part. All right, hopefully you're feeling good up until this point, because like I said, it's just regular derivative stuff with a couple extra steps at the beginning and the end. That extra step at the end is we're not done yet because we want to solve for y prime. Right now we have an expression for y prime over y. So if we want to isolate y prime, we can multiply both sides by y, and we know what y is in terms of x because that's the original equation up here. It says y equals x to the sine of x. So the very last step in the logarithmic differentiation process is to isolate y prime and then plug in for y whatever it was at the beginning of the problem, which in this case was x to the sine of x. So our final answer is that the derivative of y with respect to x, y prime, is x to the sine of x times everything in brackets here. All right, so that's the final answer. This was a pretty straightforward problem. I would argue they're all straightforward, but the problems on your math exam are probably going to be more fully loaded. So let's do an example like that, which is going to be the same process as this one, but there's a lot more steps just because the original expression for y has more stuff loaded into it. Okay, so this problem is a lot more representative. All right, so this problem is a lot more representative of what you'll probably see on your math exam. So, but really it's just more of the same stuff. And instead of writing it all out, turning this into a 20-minute video, I want to use a tool that I'd like to share with you guys called MathGPT Pro. That'll help us solve it. So let me screenshot this and I'll paste it into the software. All right, so MathGPT Pro. This is like ChatGPT, but it's user experience and like neural network or whatever. I'm not a machine learning engineer. I don't really know. Are optimized for math problems. So there's like a lot of really cool features, which you'll see, that are really helpful for like your math class. I would have loved to have something like this when I was in school. I was always using Chegg, which this is very similar to Chegg, but it's AI. It never gets annoyed with you. It's like immediate, it's personalized. So let's do it. So let's use it to solve this problem. Y equals this whole mess, and you just like paste the screenshot in, and then you like ask it a question. So solve for dy dx given y below. Use logarithmic differentiation step by step. So let's see what it says. All right, so step 1, take the natural log of both sides, like we did in the first example. So did ln y equals ln of this big expression. Use properties of logarithms to simplify the expression, which is like what we were doing in the last problem as well. So what did they do? It looks like they split it up using like ln of a times b equals ln of a plus ln of b. So that's how they split up ln of x to the 5th plus ln of e to the x plus ln, etc. And then when you have the natural log of a quotient, it's like you can split it up into a difference, which is why they got this minus ln 5 squared minus ln, etc. And then they continued using property of logarithms, so they like move the 5 down in front. Ln of e to the x is just x. And the cool part is, like, anytime during its answer, if you get confused, one of the features they have, which is like why this is better than just using ChatGPT, you can screenshot to ask. So I click this, like let's say I didn't know what these properties of logarithms were. I can like screenshot step 2 or like some subset of step 2, and I can be like, what properties of logarithms would you use in step 2? And it lists them out. So like ln of ab, like I said, is ln of a plus ln of b. Ln of e to the x is x. It's like these properties allowed me to simplify the expression by breaking it down in terms of the blah, 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 blah. So let's see, let's keep going through its explanation. Step 3, it like differentiated both sides with respect to x. So it did like the whole y prime over y. In this case, they wrote it as 1 over y times y prime. Equals, and then they were differentiating this part, so they got like 5 times 1 over x plus derivative of x is just 1, plus then they use the chain rule here, so it's like derivative of the argument divided by the argument is 4 over 4 plus x. This is just a constant, so they got 0, and they keep going like this. And then they solve for dy dx, so this is, like I said, that last step for logarithmic differentiation. You like move the y to the other side, and then you plug in for y. And in this case, y was like very hairy. It was this big expression. But that's it. So it's like the derivative is given by the expression above. And that's what you'll find in all these problems is the answer. It's like, no way, this is really the answer. This is too messy. But it is. So like I feel bad for the professors and teachers that are having to grade these because there's so many ways you could simplify this and they're all the correct answer. And then I really liked this answer, so I'm going to give it a smiley face. I want to give the feedback to the machine learning team at MathGPT that they did a good job with this one. They're always improving their product. Like, for example, they have a mobile app as well. It makes it easier to like post your screenshots. Or like you could just take a picture with your phone and it'll help you with that problem. And there was like a bug with it and I let them know and they fixed it like immediately. Oh, another thing that I forgot to mention, then I'll like move on from this ad and you can move on with your day, is that they're backed by YC, which in like the AI space is like a really big deal. Like Y Combinator is where I think like ChatGPT came out of, something like this. It's like an ethos thing. But anyway, the very last thing I'll say is that this is it's only $6 a month, and if you use the link in the description, you get like $2 off your first month. So logarithmic differentiation, not too bad. You just do ln of both sides, apply properties of logarithms, differentiate, and then multiply by y on both sides. You're good to go. I hope you guys have a good day.